Where in the US are tsunamis most likely to strike? You probably remember it well. Exactly 20 years ago, on December 26, 2004, a tsunami triggered by a 9.1 magnitude earthquake devastated all of Southeast Asia. It was one of the greatest natural disasters in history. The underwater quake was recorded off the coast of Sumatra, and the subsequent tsunami caused enormous damage, especially in Indonesia, Thailand, and Sri Lanka. The towering waves also reached the shores of India, Malaysia, the Maldives, Myanmar, the Seychelles, Somalia, and Tanzania. Entire villages were wiped out. There were 230,000 victims and 1.7 million displaced people. According to estimates, the devastation caused $13 billion in damages just for emergency interventions. In this video, we will delve into the geological processes that lead to earthquakes and consequently tsunamis, highlighting at the end the regions of the United States that are most at risk of flooding. By now, everyone knows the term tsunami, synonymous with tidal wave, comes from the Japanese Tsunami, which means harbor wave. A tsunami refers to an abnormal and massive sea wave triggered by a violent underwater earthquake or other events that cause a sudden displacement of a large mass of water, such as a gigantic landslide or an underwater volcanic eruption. Usually, a tsunami forms in the open sea, where the wave remains low and barely noticeable, gaining strength only near the coast. As the wave approaches the shore, the friction with the increasingly shallow seabed causes it to rise and crash inland as a towering wall of water. Unlike traditional sea waves produced by wind and currents, a tsunami acts as an intense underwater disturbance involving the entire water column, from the seabed to the surface. The displaced water propagates progressively on the surface, creating very long surface waves, sometimes hundreds of kilometers or miles long, extending across the entire ocean surface, like when a stone is thrown into a pond. To give you some numbers, tsunami waves, when crossing a vast ocean like the Pacific, can have lengths of about 250 to 300 kilometers or 155 to 186 miles, reaching impressive propagation speeds of 600 to 700 kilometers per hour or 373 to 435 miles per hour. In the open ocean, over very deep waters, the wavelength of a tsunami, the distance between waves, can be hundreds of miles, but the waves themselves may be barely noticeable and rarely more than 3 feet high. Sailors at sea usually won't notice tsunamis as they pass under their hulls. However, as the tsunami approaches the coast, the increasingly shallow seabed slows it down due to friction. As this happens, the principle of energy conservation causes the wave height to increase dramatically, forming a true wall of water that crashes onto the shores with great force in a series of large waves that penetrate inland for kilometers or miles. However, a tsunami does not always present itself as a rising wall of water crashing onto the shore. In some cases, depending on the seabed characteristics, the wave may appear more like a large high tide, invading the land for several kilometers or miles where there are extensive plains. It's important to remember that a tsunami comes as a series of waves, not a single wave, and can last for days in some locations. Additionally, not all tsunamis behave the same way, and a tsunami can affect coastlines differently due to coastal and offshore characteristics. Coral reefs, bays, river inlets, underwater features, and the slope of the beach can influence the size, appearance, and impact of tsunamis when they hit the coast. A small, non-destructive tsunami in one place can be very large and violent just a few miles away. The area most affected by these phenomena is the Pacific Ocean, where most events are concentrated along the Circum-Pacific Belt, often referred to as the Ring of Fire due to the presence of a large number of active and inactive volcanoes, some of the largest in the world, such as Mount St. Helens in the USA, Popocatépetl in Mexico, Cotopaxi in Ecuador, and Mount Fuji in Japan. Along this ring, 8 tectonic plates meet with the larger Pacific Plate, the Nazca Plate, and the Cocos Plate. The 5 strongest earthquakes of the past 100 years have generated equally destructive tsunamis, 4 of which occurred along the Pacific Ring of Fire, in Chile, Japan, and Alaska, with the sole exception of the 2004 Sumatra tsunami, which struck the Indian Ocean. Large-scale tsunamis are very rare, as they require earthquakes of magnitude 8 or higher as triggers. Such earthquakes occur on average about once a year. Considering that only about 1 in 10 of these quakes occur beneath or near an ocean, and thus under conditions that can generate a tsunami, it can be said that significant tsunamis occur globally with a frequency of less than or equal to 1 every 10 years. A truly frightening thought. But how do such monsters form? Whatever the cause, the formation of a tsunami is always linked to the sudden displacement of significant volumes of rocky material on the seabed. In 80% of cases, this occurs due to an earthquake caused by the collapse of an underwater fault. In the 20th century, there were numerous tsunamis of seismic origin, just to mention the main ones. On November 5, 1952, a massive 9.0 magnitude earthquake off the coast of Kamchatka generated waves over 18 meters or 59 feet high, causing an estimated 15,000 deaths. However, there is little information about this tsunami because the then USSR did not disseminate news and data, keeping most information secret, with the first reports arriving only years later. This is why the event is remembered as the secret tsunami. On May 22, 1960, Chile was hit by the strongest earthquake of the 20th century, known as the Valdivia earthquake 9.5, which triggered a violent tsunami with waves 15 to 20 meters or 49 to 66 feet high on the coasts near the epicenter. It reached Hawaii about 15 hours later, with waves over 10 meters or 33 feet high, and nearly 24 hours later, it also hit the coasts of Japan, 10,000 kilometers or 6,213 miles away, with 6-meter or 20 feet waves. On March 27, 1964, a 9.2 magnitude earthquake struck Alaska, generating a tsunami with waves that reached Hawaii and extended along all the American Pacific coasts and into California. Only the low population density of the region prevented a higher death toll. Another possible cause of tsunamis is landslides, which occur in 11% of cases. When a portion of a mountain near the coast collapses, the volume of rock that breaks off falls into the sea, displacing significant volumes of water. Interestingly, the highest tsunami wave ever recorded occurred on July 9, 1958, in Lituya Bay, Alaska. Due to such an event, a gigantic landslide where about 30 million cubic meters, or 1.06 billion cubic feet, of rock fell into the sea, displacing an enormous mass of water. The resulting wave reached an incredible height of 525 meters, or 1,722 feet. Landslide-induced tsunamis are more localized phenomena than those produced by large earthquakes. Even though, as we have just seen, they can reach exceptional heights, the waves, always single, travel short distances before crashing onto the shores of inlets, fjords, or even lakes. In terms of importance, underwater volcanic eruptions come next in the statistical count, contributing only 6% to the triggering of tsunamis. During these events, violent releases of volcanic material and gases can, in some cases, displace large amounts of water. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. But can all underwater volcanoes create tsunamis? Actually, no, because the energy of the eruption tends to dissipate in the water column. A real tsunami risk would only exist for those volcanoes whose peaks are less than 500 meters, or 1,640 feet from the sea surface. A modest percentage of risk, 3%, is due to so-called Meteotsunamis, which are much weaker tsunamis caused by rapidly moving meteorological events, such as strong thunderstorms, squalls, and other storm fronts. These meteotsunamis are similar to those generated by earthquakes. Their development depends on the intensity, direction, and speed of the atmospheric pressure disturbance as it travels over the ocean, as well as the ocean's depth. Meteotsunamis are regional, and some parts of the world are prone to them due to a combination of factors such as local weather patterns and the shape of features of the Earth's surface, both above and below the ocean. Want a couple of examples? June 13, 2013, northeastern United States. Waves similar to those of a real tsunami hit the coasts of New Jersey and southern Massachusetts. Despite clear skies and calm weather, at Barnegat Inlet, New Jersey, 3 people were injured when a 6-foot or 1.8-meter wave swept them off a jetty and into the water. After ruling out other sources, scientists determined that the waves were generated by a so-called derecho, a high-speed windstorm that had passed through the area hours earlier. June 21, 1978, Vela Luka, Croatia. Without warning and in relatively fair weather, flood waves inundated the port town of Vela Luka. Scientists eventually identified the source as atmospheric and called it the strongest meteotsunami ever recorded. This event hit waves 19.5 feet or 6 meters high, lasted several hours, and caused millions of dollars in damage. At this point, some of you might be wondering why we haven't mentioned one of the most popular natural disasters among doomsayers: asteroid impacts. The omission is because in recent history, there has never been a tsunami caused by the fall of an object from space. Or at least, we have never had proof of it, except for the event 66 million years ago that led to the Great Cretaceous extinction. But that was a truly unique case, statistically insignificant. It has been calculated that at least 10 objects no larger than 1 meter or 3.3 feet fall into the sea each year, a size not capable of causing noticeable effects. But where have the most destructive tsunamis already struck? And where might they strike again? As we have just seen, tsunamis can be generated in all the world's oceans, inland seas, and any large body of water. However, some areas are particularly prone to this phenomena due to their unfortunate location. Of the 754 events confirmed in the Global Historical Tsunami Database between 1900 and 2015, about 78% occurred in the Pacific Ocean, around geologically active Ring of Fire, 8% in the Atlantic Ocean and the Caribbean Sea, 6% in the Mediterranean Sea, 5% in the Indian Ocean, and 1% in other seas. Since 1900, the highest percentage of tsunamis has been generated off the coast of Japan, 21%, followed by Russia, 8%, and Indonesia, 8%. But at this point, for the benefit of the many followers that the Insane Curiosity channel has in those areas, the question we need to ask is, which are the highest tsunami risk zones in the United States? Studies tell us that a tsunami can hit any U.S. coast, but the level of risk varies significantly, depending largely on historical data, geological characteristics, and the site's location relative to faults, volcanoes, or underwater landslides. For these reasons, the U.S. Atlantic coast and the Gulf Coast states have experienced very few tsunami run-ups. The term run-up refers to the height of a tsunami wave, i.e. the vertical distance between the trough and the crest in the last 200 years. In fact, Louisiana, Mississippi, Alabama, the Florida Gulf Coast, Georgia, Virginia, North Carolina, Pennsylvania, and Delaware have no known historic tsunami run-up records. Further, only a total of 6 tsunamis have been recorded anywhere in the other Gulf and East Coast states. 3 of these tsunamis were generated in the Caribbean. 2 were related to magnitude 7 earthquakes along the Atlantic coastline, and 1 reported tsunami in the mid-Atlantic states may be related to an underwater explosion or landslide. In contrast, all U.S. coasts in the Pacific Basin have a moderate to very high tsunami hazard based on both frequency and known run-up amplitudes. The sheer number of run-ups and the large number greater than 3 meters or 9.8 feet observed in Alaska and Hawaii justified assigning a very high hazard for these two states. The Pacific territories, including Guam, American Samoa, and the Northern Marianas, experienced many tsunamis, but only one event had an amplitude greater than 3 meters or 9.8 feet. Both the frequency of tsunami run-ups and the amplitudes support a qualitative high hazard assessment for Washington, Oregon, California, Puerto Rico, and the Virgin Islands. The high value for Oregon, Washington, and Northern California reflects the low frequency, about 1 per 500 years, but the potential for very high run-ups from magnitude 9 earthquakes on the Cascadia subduction zone. There are no known deaths from tsunamis along the U.S. Atlantic coast or Gulf Coast, and only one known death in the Pacific territories, on Guam. In contrast, both Alaska and Hawaii have unfortunately experienced several hundred deaths each from tsunamis. Tsunamis in Puerto Rico and the U.S. Virgin Islands have caused a total of 172 deaths. The U.S. West Coast has had 25 tsunami deaths, but due to the lack of written records, there are no estimates of deaths caused by the Great Cascadia earthquake in 1700. There is evidence from oral traditions and computer simulations that this event must have severely impacted native populations. In recent decades, much of the research on tsunamis and earthquakes has focused on the Pacific Northwest coast, where increasing evidence points to large earthquakes and tsunamis in the past, and the potential for more in the future. The source of these earthquakes and tsunamis is the Cascadia subduction zone, which lies primarily offshore and extends for about 700 miles or 1,100 kilometers from Cape Mendocino in Northern California to northern Vancouver Island in Canada. Before the mid-1980s, it was thought that the tsunami hazard for these regions could only come from distant tsunamis. This was mainly because there were no written records of such events, and it was believed that the Cascadia subduction zone was incapable of producing large earthquakes. But now we know that this region has historically experienced such earthquakes and tsunamis, and is likely to do so again in the future. In the past decade, experts have used new data to make tsunami predictions for dozens of other active subduction zones around the Ring of Fire, and at the top of this list of high-risk locations is the Cascadia subduction zone, a 600-mile or 965-kilometer fault that stretches from Vancouver Island, Canada, to Northern California. Its last big one was in 1700, and current estimates indicate about a 15% chance of a magnitude 9.0 earthquake in the next 50 years. Compared to the other 30 subduction zones analyzed by the study's authors, Cascadia ranked 5th in terms of tsunami severity, behind subduction zones like Makran in Pakistan and Iran, the Aleutians in Alaska, and the Lesser Antilles in the Caribbean. So what about the world's most famous fault, the San Andreas Fault? What kind of destructive tsunami could it generate in the Los Angeles area? Surprisingly, contrary to popular belief, to trigger a tsunami, an earthquake needs to displace the ocean floor, and most of the San Andreas Fault is on land. Therefore, the quake would only generate small waves, nothing dangerous. What Southern California should fear instead are tsunamis from distant sources, typically from Japan, Chile, or Alaska. The worst-case scenario for Southern California is the arrival of a tsunami generated by the eastern Aleutian Islands in Alaska. It would take about 5 to 6 hours to reach the American coast, giving some time for notification and evacuation. However, when it arrives, it could produce waves at least 7 meters or 23 feet high. Perhaps even more dangerous for Northern California, because it would leave only a few minutes of warning, could be the arrival of a locally generated tsunami, which, as we have seen, can be triggered by sudden offshore fault movements or underwater landslides. Northern California could experience a significant local tsunami event generated by a strong earthquake on the Cascadia Subduction Zone fault. This type of event could cause at least 6 minutes of shaking, giving people 10 minutes of warning before waves up to 50 feet or 15 meters high hit Crescent City, which is the city at the highest risk of tsunamis in the state. And finally, a couple of useful tips. The main risk factor of a tsunami, as we know, is its unpredictability, as it is mostly associated with earthquakes, which themselves are unpredictable. When a tsunami approaches the coast, it is not a wall of water that we see coming from afar. What is initially observed is a tide that rises very quickly, and the fact that it is far from the coast gives little perception of its size and speed. Fortunately, before facing the wall of water, one can observe the phenomena of the gradual retreat of the waters. In the absence of an alarm system, this is the only real warning sign of an approaching tsunami. The retreat occurs about 5 minutes before the wave and is very noticeable, with the water receding from the coast by tens of meters or yards, even leaving boats stranded on the seabed. If you ever see such a phenomena, the first thing to do, if possible, is to move away from the coastal area, lagoons or other bodies of water, and head to a higher location, at least 30 meters or 98 feet above sea level. On foot, if possible, because most likely thousands of other people will be trying to leave by car at that moment. Despite its speed, the long wavelength of tsunami makes the period of these waves very long. It can happen that many minutes pass between the arrival of one wave and the next, and the tsunami can last for several hours. So once you find a safe refuge, do not trust returning after the first wave has passed. If you cannot move inland because access is blocked, quickly choose to climb somewhere. If the area has been hit by similar phenomena in the past, it is likely equipped with so-called evacuation towers, sturdy structures about 30 meters or 98 feet high, with a platform that can accommodate hundreds of people. In the absence of these structures, head as soon as possible to a multi-story building, making sure if possible to choose one of the sturdiest. Other advice, as you can understand, would be completely useless if the situation were already compromised and you suddenly found yourself struggling in the waves. In these cases, survival would depend only on your individual ability to survive at all costs, and also on a lot of luck. But the United States, thinking about it, is a big country. Why not consider the idea of leaving the coast and taking refuge in the Great Plains or the Appalachians?